In this video, I want to have a look at sequences. So there's lots of things that happen in nature or in real life that follow a given pattern or rule. For example, if we had cells. So we're going to start with one cell. That cell is going to divide into two, so we've got two cells. Each of those is going to divide again, and we'll have 4 cells. Divide again, and we'll have 8, and it keeps going on. So we end up with this sequence of numbers that follow a given rule, that each time if we want the number of cells, we're going to multiply it by 2. So that's called a sequence. So a sequence is an ordered set of numbers that follow a given pattern. A series, which is the broader topic that we're going to look at in this whole next couple of weeks. So a series refers to the sum of those numbers in the sequence. So if we had commas in between these, 1, 2, 4, 8, 16, 32, that's a sequence. But if instead of those commas we had pluses, then it becomes a series instead. We need to know a little bit of notation that we use. So we call the first term of a sequence or a series, we call it T1. We'll call the nth term Tn. So for example, if we had the 4th term, it would be T4, 20th term would be T20, and so on. So all of our sequences will follow a given pattern. Sometimes we'll be given that pattern, other times we'll have to work it out. So let's have a look at a few examples. So our first example asks us to write down the first 3 terms and the 20th term of the sequence Tn equals 2n minus 1. So if we want to find the first term, we've got to have T1. So we're going to have 2 times 1 minus 1, which would just give us 1. The second term would be 2 times 2 minus 1, which would give us 3. The third term would be 2 times 3 minus 1, which would give us 5. If we wanted the 20th term, we're going to substitute 20 in there. So we'd have 2 times 20 minus 1, which would give us 39. So all we're doing for each of those is substituting them into the formula or the rule that was given to us. In some examples, our rule will be given to us in a different form. So instead of just being based on n this time, we're saying to find one term, we're going to take the term that comes directly before it, and we're going to add 5. If it's written like this, we also need to know where to start, so you'll have to be given another piece of information. In this one, it's telling us that the first term is 8. So we know that T1 is 8. If we want to find the first 4 terms, we already know the first one. T2 would be equal to T2 minus 1, which is T1 plus 5. So that's going to be 8 plus 5, which would be 13. So we're just taking the term before it and adding 5. So T3 then would be T2 plus 5, which would be 13 plus 5, which would give us 18. T4 would be T3 plus 5, so 18 plus 5, which would give us 23. So this rule here would be the same as if we had Tn is equal to 5n, didn't mean to do that, n so little, 5n plus 3. So we can double check that. If we had a 2 here, we'd have 10 plus 3 to give us 13. If we had a 3, we'd have 15 plus 3 to give us 18. So these 2 rules mean exactly the same thing. In our third example, we're asked to find the first term of the sequence n squared plus 3n minus 8. So we want the first term that exceeds 200. So what we're going to do, we're going to write n squared plus 3n minus 8. We want to know when that is greater than 200. So we're going to solve this quadratic inequality. So we're going to have n squared plus 3n. We're going to subtract 200 from both sides. So we're going to have minus 208 is greater than 0. Now if I factorize that, I'm going to have n plus 16, n minus 13 is greater than 0. Now to solve a quadratic inequality, we always want to draw a really quick sketch. So this quadratic is going to have roots at minus 16 and plus 13. So minus 16, and we're going to have plus 13. It's a concave up parabola, so it's going to look something like this, just very roughly. And we want when that quadratic is greater than 0, so we want either this section or this section here. So we either want when n is less than minus 16 or when n is greater than 13. Now, we don't deal with negative numbers when we're talking about sequences, so this one's completely out. So we want when n is greater than 13. So if we looked at the 13th term, that would be exactly 200, but we want when it exceeds 200, so that means we have to go to the next term, which would be the 14th. So the 14th term is greater than 200. You can always double check those as well. So if you plugged 13 into here, you can double check that it gives you 200 and that the next term along the 14th term is the first number over that. So for our next example, we've got, is 80 a term of the sequence 2n plus 7? So if it is, there has to be a whole number n that's going to give us an answer of 80 here. So what we're going to do, we're going to write 2n plus 7 is equal to 80, and we're going to solve this. Again, if n is a whole number, then it is part of our sequence. So we're going to subtract 7, and we'll have 2n is equal to 73, which means that n would be equal to 36.5. So because it's not a whole number, the 36th term will be just under 80, and the 37th will be just over 80. Therefore, 80 is not a term in our sequence. All right, so that's an introduction to sequences.